Hello, everyone. Guess wait just a quick bit for anyone else to join. You'll be able to drop your questions in the message box. So we'll have a QA session at the end of this webinar to address all your questions. All right, let's get started. Welcome to this webinar session, Beyond One Size Fits All, the right energy model for your design goals. Very suggestive title. So we will be answering uh, one one main question throughout this session, and that is how do we determine which approach is right, which energy modeling approach I mean is right for your project's goals and needs. What's needed to make the most out of your energy modeling endeavors. So the learning objectives are, first of all, understanding the energy modeling landscape, just a quick overview of the energy modeling's role in building design and why different project goals require different modeling approaches. Uh, then we will go in detail with energy modeling levels to understand the difference that exists between conceptual modeling, detailed modeling, compliance modeling, and even advanced research modeling. Uh, the objective three is model matching. So once we understand the different levels of energy modeling, uh, we can choose what's the best option for our current design stage. And then, as I said, space for Q&A in case you have any follow-up questions. So for the landscape, you've probably already heard at least once in your life about energy modeling. But yeah, mainly building energy modeling is used to inform project specific decisions. It allows the stakeholders to visualize and quantify real world impacts of their decisions. And this helps them find a balanced solution that addresses the client specific constraints, like let's say aesthetic preferences or budget, while still optimizing for energy performance. And green building certifications or compliance goals. I will also say that often building energy modeling is used near the end of the design process to justify, let's say, certification points or incentive programs. But and that's not a bad thing. But the real strength of building energy modeling is to provide input to design decisions through the entire design process. So one key aspect is addressing project constraints. Let's say a client may have building requirements or design requirements that counter energy efficiency in terms of needing large window to wall ratio, right? So building energy modeling helps maximizing the efficiency opportunities, even in areas where we have restrictions. So it exploits every flexibility we have in the design. As you can imagine, like, I mean, this is just an example image, but let's say certain design criteria for this building here um, has been fixed. So, but there's always, through building energy modeling, you will always find ways to play with other variables that could bring the project to a more optimal point. Also, I mentioned this design life cycle optimization. So this graph here what shows is the effect that energy modeling has over the life of over the life cycle of design. So the earlier you do it, the best way you can impact the cost and efficiency of your building at a less project cost. So what we often see is in typical design processes, these kind of efforts get done towards the end, and then the cost is of course higher because everything is already uh, spec'd out, and any design changes uh, are way more expensive. If we implement this process from the pre-design phase, we can accomplish a lot with way less uh, resources. So yeah, it's about visualizing the construction and operating cost trade-offs at both the component and the whole building level. Um, so very often we also see energy modeling being used to evaluate energy conservation measures in terms of payback. So when you calculate operational savings that accrue after initial capital investments, um, you can balance that out with the upfront cost. And sometimes energy modeling even pays for itself pretty quick, even before construction ends or the building is operational. So it's also really about identifying unnecessary costs. An example of that could be like when the HVAC design is oversized. So you're specking out probably an expensive and unnecessary system that will do the work, but won't be the most efficient option for your specific design. And as well, there's also the certification and compliance part to it. So for LEED, Passive House, well, BREEAM, all these at some point and at some level have some energy modeling uh, involved or required to maximize point obtention, and that is not just because, right? Uh, these certifications try to embed that process into building design to attain sustainability goals. And on the other side, we also see, which is not unrelated, all the compliance goals, whether that's 90.1, CONCHEC, or local regulations like Title 24, Cal Green, or any energy incentive um, for energy reduction available at your locality. That's kind of the overview picture of the uses of energy modeling. But then we need to talk about the levels that exist to really understand how we can choose our right level for our project. So in the universe of energy modeling as a concept, it could be quite abstract. So it's always a good idea to narrow things down to a reference standard. In this case, and for the US, we mainly refer to ASHRAE standard 209. This will be kind of the energy modeling, will define the energy modeling universe in terms of the different levels that are available there, from conceptual to compliance levels. And then we have this little plane here navigating in and out that universe that is advanced research modeling. So yeah, research could be applied to any different phase or level of modeling, but it also gets out of it and goes beyond. Like most often, product manufacturers are interested in some more detailed, more cutting edge level of modeling uh, to prove their product works for a certain application, right? So we also have that, but this time we will talk mainly about the ASHRAE standard 209 levels. So first of all, conceptual modeling. It's composed of these 5 different cycles, which the first 3 are not called cycles, but it's part like of the initial minimum analysis you would need to consider to actually be in a good place to start energy modeling. So climate and site analysis, you have to have that in to consideration. Local conditions impact on performance, that being exterior temperatures, relative humidity, wind speed, solar radiation, cloud cover, precipitation, all related to the site. Then you also need to do some benchmarking. You always need to compare to something. So defining what's the baseline for that building, what is the energy consumption of similar building uses. It's very wise to do very early on pre-design phase. Uh, there any you can use any sort of reference uh, for existing building data, but of course these that I put here are solid, are more advisable. That is DOE, FEMP, EIA, CBEX data, or RECS, portfolio, Energy Star Portfolio Manager, Target Finder. You're probably familiar or have heard of any of those before. And if not, I strongly advise you to take a look into those. And then design charrette, this is a step that often comes overseen. Uh, and that is uh, early in the project, all the involved, all the interested parties sitting down and setting the performance metrics, the performance goals, what are the potential energy efficiency measures to look at, what's the financial criteria, and what tasks are to be done by each party. So that helps really defining project baseline and its goals. It establishes the frame, the work frame. And then we start with the modeling cycles. Once we have our general picture of what we want to do and what we are comparing against to, we can do simple box modeling, which is main objective is to identify major performance drivers, uh, but just based off basic form orientation, like basic main major characteristics, that is climate and site analysis, together with the building form and orientation, uh, glazed versus opaque ratios, and overall envelope insulation levels. A cycle number two would be a concept design model in which energy consumption is broken down, already including additional elements as shading, daylighting, different envelope options, and the possibility of doing passive conditioning strategies like natural ventilation. So in this phase, in this cycle is where you want to exploit all the characteristics of your building and your site to minimize the need of mechanical and electrical systems to provide comfort to your building. That defines kind of the level of conceptual modeling, and then detailed modeling uh, goes beyond and starts with a low reduction model, which basically you would always like to do before as part of the process of HVAC design. In this part, you also make an energy breakdown, but now by end use, and you establish the peak heating and cooling loads for your building in a way that you can see uh, high impact peak load and HVAC sizing reduction strategies to map them and explore them in detail later. Uh, this consequently follow to HVAC system selection. Once you know your peaks, you know your energy consumption profile and your thermal profile, you can start comparing different options and see how that impacts demand and the final annual energy consumption. Let's say this is where more detailed the whole year simulation starts to really uh, have a weight. And so this will assess the project to set what are the recommended HVAC concepts. Design refinement is furtherly exploring the options we have set through the previous analysis, and we can refine the main goal is to refine at least one of the building systems, and that is HVAC lighting envelope, service water heating, or even process loads if you have a special application in your building, or plug loads is if it's just uh, uh, building that uses a lot of uh, connected load. Design integration and value engineering. This is where you really get the most information also about the financial aspects of the measures you are comparing. And you try to identify a global optimum point, which kind of yeah, accomplishes different building, different project objectives you have. You want to basically do cover the most ground with the less work. So you could already have several good strategies that optimize certain aspect of your building, but then through design integration, you really need to understand how the different efficiency measures affect other disciplines to find the one that uh, provides the most benefit at the less cost. So it's kind of a balance of how systems are optimizing and interact with themselves. And it also has consideration of time constraints, budget constraints, and complexity. These three elements should always be factored in to really make the best decision. Um, and then cycle 8 and 10 are what we would see for certification, for compliance, asked, requested by authorities, local authorities having jurisdiction, and that is as designed or as built performance. So that's when you already decide everything. You want the model to demonstrate your design and prove it for compliance. Yeah, I mean, owners realize that even having a building energy modeler on the team from the start can provide valuable insights from the beginning, and then it avoids them needing to get someone on board towards the end, which is generally speaking way more expensive because there's much more work and documentation to be done. And yeah, compliance modeling. Uh, so we typically have heard of it as cycles 8 and 10, but in the ideal world and how things should be, and if we want to follow a standard, at minimum we should do uh, the first pre-designed analysis part, that is climate and site analysis, benchmarking, and design charrette plus low reduction model, and then we can choose whatever level of the cycles 2 to 7. It's more suitable to our project, and finally it's up to the authority having jurisdiction what stage of uh, decision made, design, or as built, or even post occupancy. Uh, that's just trying to say after every decision has been taken, uh, is going to be requested in terms of documentation for the energy model. And then we also have other fun stuff. As I said, in energy modeling, we can explore. Uh, there are certain applications of very different colors and flavors. Uh, I show here these three because I think they're more related to what an architectural scope would look like or would try to look like in any building that requests this more detailed analysis. So we can explore facade thermal conduction behavior, or the envelope in a more uh, accurate way. That of course we all have heard about daylight, but there's also glare analysis, which is very important and often overseen in design. Uh, and then we also have CDF, that's computational fluid dynamics, airflow, uh, and thermal assessments. That's especially important when you're designing a building in which comfort is a very sensible aspect. and so this allows you to see the air velocity and map out the airflow in a way you can prevent discomfort at a very very accurate uh, way, and this informs in a in like a feedback loop the HVAC or the lighting design or the envelope. So all these kind of more detailed analysis are working parallel with the energy and can be integrated so that any tweak you make to design can also be translated to the building systems and ultimately to the energy performance. But this allows you to also not oversee what the interior quality and environment of the building will be. And then just very quickly, model matching. So what we've seen so far can be classified in different design stages. So pre-design, as we said, is about uh, doing your do work in climate site analysis, benchmarking, and getting the people, the stakeholders together to make a design charrette. Then in design, you can is really where you have the the wider variability of the degree of detail you want to attain for your energy modeling scope. Um, but concept design, generally speaking, you can just go with simple box modeling, and you will get very very relevant information without needing to spend a lot of time or resources in it, and that can generate your concept design modeling. For schematic designs, you would expect to be working with load reduction modeling or HVAC system selection. In design development, you are already refining the options or the strategies you defined in the previous stages. So refinement and design integration modeling, and construction documents is just tweaking minor things in terms of any uh, last minute update to construction documents. As built, uh, generally speaking, is what the, authorities would request for compliance. And a very interesting area of energy modeling is as well calibrating uh, the existing energy models once the building is operating. So you can actually compare uh, if your design is doing what you expected, and if this also informs building operators and property managers, and really it makes the ongoing improvement, ongoing efficiency management of the building possible. Um, so that's that. And with that, I will open the floor. If there's any questions, I can happily address them. Okay. Well, as you know, you can always reach us uh, in our social media or through an email. If you're a Cove user, you can also do live chat. We're happy to um, answer any questions. Okay, there's one here. I will answer it. What would you say is the biggest misconception that people fall into when selecting an energy model? Yeah, so I think uh, it's like this phrase. I don't know if you're familiar with, but trying to kill an ant uh, with a bazooka. So it's the misunderstanding of the scope that generally makes people choose a very heavy option um, when they actually um, just need to identify like the main drivers for their project. Mm, so yes, like design teams often restrain themselves of doing energy modeling when they are early in design because they think it's going to be super expensive or super it's going to take a lot of time to get some results. And the truth is that it's not like that. Even without knowing uh, much about the building, there are ranges of action uh, anyone can define from the very beginning of a project, and that will let you know what's the energy modeling scope you're looking for. Okay. Uh, well, uh, it's been a pleasure to be with you today, and have a great rest of your day. Keep energy